Hello, welcome along to a brand new episode of the Fun Kids Science Weekly. This is the only show that vows to explore the universe and find out all the sciencey secrets that are lurking inside and get you back home in about half an hour. My name's Dan, thank you so much for listening. Now this Monday, June the 1st, is in the UK anyway, it's National Dinosaur Day. So to celebrate, we've got a dinosaur special. Going back in time, loads in the podcast this week. We'll talk to a paleontologist all about how he discovers new dinosaurs and then names them. Also, we'll have a look at a brand new creature that scientists have just found, and they think that it lived 45 million years ago. And also, we'll learn why it's related to something that you might find on a pizza. That is true, it's on the way. And I'll also answer some of your questions. Today they're on hearts, blood, and insects. That's all on the way. First, let's travel back through time and get an episode of Age of the Dinosaurs.
Age of the Dinosaur with Dinosaur Action Magazine, the #1 mag for dino fans.
Imagine going back in time, not 100 years or 1,000 years, but millions of years. To the Age of the Dinosaur. Welcome to the Jurassic Period, which existed between 145 and 200 million years ago. At the start of the Jurassic Period, there was just one huge continent called Pangaea. And with no frozen ice caps, sea levels were much higher than they are today. And much of the Earth's surface was therefore underwater.
Uh-oh, something's moving.
We better watch our step. During the Jurassic Period, Pangaea began to separate. The northern half, called Laurasia, started to break away, forming North America and Eurasia. What we otherwise call Europe and Asia, from the southern half, Gondwana, that included Antarctica, Madagascar, India, Australia, Africa, and South America.
There's a whole new ocean.
Lagoons and massive lakes initially formed in the spaces created by the moving land masses. Eventually, these became the oceans that we know today. The Jurassic Period was much hotter than we experience today. With hot and dry deserts in the middle of the land masses, huge sticky swamps along the coast, and vast forests full of giant ferns and tall leafy green conifers in between. And all sorts of dinosaurs were flourishing, like the knobbly armor-covered Scelidosaurus. Scelidosaurus was a dinosaur which lived in early Jurassic times. Like his close relations, the Stegosaurus and Ankylosaurus, he was a herbivore, meaning he only ate vegetation, not other animals. But with his beak like a mouth and bony horns, he would have been pretty scary.
Watch out for his tail. He's swinging it this way.
Phew, that was close. Obviously they aren't around today, but fossilized skeletons of Scelidosaurus found in England have been some of the most complete skeletons ever found, meaning that we know more about Scelidosaurus than many other dinosaurs.
Paleontology. Pick.
Today, there are 7 continents on the Earth. Europe is one, the others are Asia, Africa, North America, South America, Antarctica and Australia. But how do we know that there used to be just one continent?
Paleontologists can tell this from fossils and animal life. By investigating land mammals on different continents, but which come from the same family, scientists can conclude that the only way they could travel such great distances is that they originally came from the same place. One example is the extinct freshwater reptile Mezzosaurus. It was a bit like a lizard, and it has been found in Brazil and West Africa, 2 places that are now thousands of miles apart. The Mezzosaurus would never have been capable of swimming such a vast distance.
Age of the Dinosaur with Dinosaur Action Magazine, the #1 mag for dino fans.
It's time to answer some of your questions then. It's so easy to get yours answered. You need to leave it for the show. Find the Fun Kids Science Weekly over on Apple Podcasts. There's a little comment box at the bottom. That's where you write your question. That's what Sam has done. And then Sam wants to know, how do defibrillators work? Now, defibrillators are used when the heart rhythm changes into short, sharp pulses. So instead of going ba-dum, 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 it goes like ba-da-ba-dum, ba-da-ba-dum. I could do this all day. Anyway, it changes the way your heart beats. Now, this means that it can't push blood around the body well enough. When that happens, things can get quite serious, so you have to use a defibrillator. And what it does is the same as a computer, turning off and on again, really. You use two paddles, which you put on someone's chest, and it sends a huge electric shock straight to the heart, which stops it. It resets it. And then the heart naturally kicks in again because it's an organ, it wants to keep you alive. And when it restarts, it should start at a normal beating rate, which stops the short, sharp, dangerous pulses. Yeah, it's kind of like turning a computer on and off again. Thank you for that, Sam. This is from Daniel, who is 10 years old, who asks if blood is everywhere in the body and where does it come from? We've done this on the show recently, I think. Talking about bone marrow. Yeah, blood is made inside your bones, in the soft, fatty part that runs through the centre called bone marrow. Now, it's made by blood cells pretty much cloning themselves in there, and then they turn into the type of blood that you need. Maybe that's red cells, maybe that's white cells, and then from the middle of the bones, from that marrow, they are pushed into the rest of your body. It's amazing, isn't it? Blood is made inside your bones. Thanks for that, Daniel. Nice name as well. And lastly, this is from Nathan, who is 8 years old, who asks, what is the largest insect in the world? A lot of ways of measuring what's large, in weight, in size, tons of ways. But at the moment, scientists in size anyway think that it's the Longhorn Beetle from South America. You need to look this up. It's utterly terrifying. They can grow up to 16 centimetres long, which is about as big as an adult's hand. They're thick, dark, brutal brutes. They look awful, honestly. They've got these pincers, they've got crawling arms, they've got a rock-hard shell as well. They look grisly. Not something that you want to look at too often. The Longhorn Beetle from South America. Thank you so much for that question, Nathan. If you want something answered on the show, you need to leave it for me as a review over on Apple Podcasts. It's the Fun Kids Science Weekly, and we've got a dinosaur special on the show this week. So on the line, we have the paleontologist, Dr. Dean Lomax. Dean, thank you so much for joining us.
Oh, it's my pleasure.
Now, I really want to hear about the process of actually discovering a dinosaur. That's what I think I've got you on to today. So I guess right at the start, how on earth do you know where to dig? We're always hearing fairly frequently at the moment about new dinosaurs that we've kind of discovered, new fossils that we're finding. How do you know where you're going to go and look, where you're going to excavate, so you can find perhaps new dinos?
It's one of the sort of secrets of the trade, if you like. No, I'm totally joking. It's based on sort of years and years of research and exploration of paleontologists who have been out sort of hunting for dinosaurs and other fossils for such a long time. And personally, for example, if I would like to go and find a dinosaur and I'd like to find one in the British Isles, I'd have to ensure I go through all the historical books to work out exactly what the right rocks are. Go to, say, the coastline, look at the Jurassic rocks on the Dorset coast, and specifically go there in search, in the back of my mind, knowing that, okay, these are the right age of rocks where we should find, say, a dinosaur, or we might find a marine reptile or a certain type of fossil, like an ammonite, a fossilized squid. And if you go to one of these places armed with that bit of knowledge, I can almost always guarantee that you will find a fossil. Most people, when they come to me, they say, oh, I can't find fossils, it's incredibly hard. And yeah, I'd agree that you're very, very unlikely to find a complete dinosaur skeleton. But I can 100% guarantee, if you do sort of read the right books, visit museums, and get to know the geology, you can go out and anybody can find a fossil.
You say look at the geology there. Why is what's happening in the rocks so important to the type of dinosaurs we would find there? Is it because the particular dinosaurs kind of kept to certain environments, much like animals do today?
Yeah, that's quite right. So you wouldn't typically expect to find, say, a terrestrial, a land-living dinosaur in a marine environment. So where you've got a marine environment where you would have had squid-like animals, fish, marine reptiles, things like that. You wouldn't expect to find a dinosaur there, although occasionally you do find them. So if, for example, you wanted to go out and you wanted to find a dinosaur, you would want to look in the rocks that we know are of a land-based sort of origin. So things that have plants, things that have, say, insects. They may have other animals that lived on land. You might have fossils of mammals or things like that, and they're the sort of rocks that you would go specifically looking for. But you kind of go out, well, if you go out looking at somewhere where you know that fossils have been found before, as I say, by looking at books or visiting museums, then that's your sort of your ace in the hole, if you like. But obviously, as a paleontologist, me and my colleagues, we also go to places that are unexplored. We have a rough idea of where we may find fossils, and sometimes we could spend weeks, maybe even months perhaps, going out looking for fossils, and we may not find much at all. But that sometimes can be the fun of it.
I imagine our map of where some dinosaurs lived around the world is pretty thorough right now. We've had quite a lot of time to look these things up. Are there any big surprises though, where a dinosaur bone has cropped up somewhere, and then after you've investigated it, you really are utterly baffled that this creature has cropped up where it is?
Yeah, it's an interesting thing that actually, because on average, I mean, this is a mind-blowing fact, for example, but on average at the moment, we're finding a new species of dinosaur every 2 weeks, which is incredible. Yeah, it is incredible. And these dinosaur species, I think we're up to about 1,600 species of dinosaur that we have that scientists recognize now, which is, it is incredible. And probably for me, not personally, but one of the most sort of mind-blowing facts of a dinosaur discovery was several dinosaurs have been found in Antarctica, under the ice, in rocks. And there was an entire expedition there back 30, 40 years ago, sort of excavating under the ice in the bedrock there. And they found, not only did they find dinosaur remains, but they found remains of plant life and insects and other animals. So they could build up the entire ecosystem. And it showed that what now is Antarctica, so of super icy conditions, back then was like a tropical rainforest. And you're talking about nearly 200 million years ago. So this is right at the beginning of the Jurassic period. But that sort of discovery is quite remarkable.
I know that you're quite an expert on dinosaurs of the British Isles, where I am right now. I know you mentioned this earlier. What did dinosaurs look like back then here where we are? What dinosaurs would we have found if I was roaming, near where I am at the moment in London, say 200 million years ago?
So going back 200 million years ago, so the British Isles, the story of dinosaurs in Britain is really quite fantastic. The entire story, and if you like, we could even say the invention of dinosaurs was right here in the British Isles. And that's because the very first dinosaur called Megalosaurus was discovered and described in 1824. And just a year later, another dinosaur, which many people may be aware of, called Iguanodon, that was named. And the word dinosaur, meaning terrible or fearfully great lizard, that was also coined here by a guy called Sir Richard Owen in 1842. And since then, we're looking at probably about 70 different species. So not an enormous amount, but still quite a few species have been found here. And, we have some really fantastic stuff. So we have the great sort of grandparent of Tyrannosaurus rex was found right here in the British Isles. It was found in Gloucestershire. And it's an animal called Proceratosaurus. Now, it wasn't a sort of massive and scary like you'd imagine like a T-Rex sort of ancestor would be. It was actually about the size of a Labrador. But it lived about 160 million years ago. Now, the cool thing with that is we are closer in geological time to T-Rex than T-Rex was to its great-great-grandparent.
These facts always baffle me. They're always ridiculous. That's outstanding. Listen, you're on your dig. You found a bone. What do you do then as a paleontologist? How do you work out who it belongs to? If you know that dinosaur already, if it's a brand new one, what do you do? What's that process?
That is one of the best processes, I must admit, as being a paleontologist. To be able to get out and explore and find something potentially new is just incredible. It's one of the reasons why I got into paleontology. And I get to do that, on a not necessarily a daily basis, but I'm always gone on expeditions. And in that particular scenario, I go out a lot to Wyoming in North America, and I work with a museum called the Wyoming Dinosaur Center. And every summer, where I sometimes spent several months there, we'll excavate an entire bone bed of dinosaurs. So we might find just a little tiny piece about the size of a sort of 50 pence coin, a piece of bone sticking out of the rock, and we'll say, right, what could this be? We'll start to excavate the rock away and eventually reveal a huge bone. And this was something we did back 10 years ago. I was working with them, and we excavated an entire femur, so an upper leg bone, of a sauropod dinosaur, something like a Dippy the Diplodocus, something like that. And this bone was, must have been nearly 3 feet long. It was enormous bone. And what we started to do from there is we not only found that bone, we found other parts of the skeleton. So in that case, we thought, okay, this must be an example of a Diplodocus. So we'd excavate the entire animal out.
Why is that? Just because of? Sorry, Dean. Is that just because of the size that you thought that it must be that?
Well, yeah. So partly due to the size, but this animal in particular. So it was a big bone bed of sort of sauropod bones. That's what Diplodocus is. One of these long-necked, long-tailed dinosaurs. And certain features on the bone, so on the femur and on other elements, we found actually fragments of a skull as well, and other parts of the vertebrae, which indicate that it is a Diplodocus. And so that's where not only then did we remove it from the ground, but at the time, that's kind of a tentative identification. So it's like, oh, we think it's that because it shows this and this. But then once you take the bones out of the ground and put them in the laboratory, you then have to remove carefully with sort of using like dentist type drills, remove all of the rock away from the bones so you can see them all. And this is something that I've been doing for about 12 years now. And in particular, that example I give that example because Diplodocus and those type of dinosaurs out in the American sort of Midwest are very common in the sort of particular rocks of the late Jurassic, a famous formation called the Morrison. But one thing I recently was involved in was the discovery of this very tiny thing in comparison to Diplodocus. Now, Diplodocus is, over 100 foot long. It's a massive, massive animal. But I found, a group of colleagues of mine as part of a research team going back 20 years, they found the bones of a tiny animal the size of a chicken, and nobody could quite know what it was. And going back about 3 years ago, I was part of this study, and we went through the same process that not only did the team excavate this little skeleton, but they didn't quite know what it was. So they'd removed all the sort of rock in the laboratory, and then a team of experts, me included, went through, looked at all the bones, and we compared it to every single other animal like that has been found around the world, and determined that was a new species to science, which was super, super exciting. And not only that, it's very closely related to a certain dinosaur called Velociraptor. And we named this dinosaur, it's a bit of a mouthful, it's called Hesperornithoides meisleri. But it's a turkey-sized little dinosaur like Velociraptor, and I'm pretty sure it would have been vicious. But it's the only one that is known anywhere in the world. So it's amazing to be part of discovering something like that.
And how do you name a dinosaur? You just gave some absolute mouthful of different consonants, really, that you kind of jumbled together. How do you figure out what it's going to be? Are there guidelines that you have to go by? Do you have to check on some database that there's not one already called it?
That last point is very interesting, because that happens occasionally. People name something, it might turn out that there's already, say, a fossil lizard been named this back in the 1800s. So you have to be careful with that. But the way in which you go about it is generally, it might be that you find, let's say, you find a dinosaur and it has a really long neck. It might be that in which case you find out what the sort of terminology is for a long neck in either Latin or Greek, and you translate that into Greek or Latin, and then that gives you your sort of name for the dinosaur. In other respects, it might be that the dinosaur is named after a certain person. So it could be the person who discovered it, or it could be somebody who's been a prolific paleontologist in the field for 100 years or something like that. And on top of it, the other thing might be, it could end up being named after the place of discovery. So if we name something, say, Wyomingensis, it would be after Wyoming and the place of discovery. But a good example might be, say, Triceratops. That name translates to three-horn face in reference to the three horns on the Triceratops's head. And sometimes, we just get to have fun with it.
Are you completely free to call it really whatever you want, or do you have to do you have to call it like the long neck lizard back in Latin, or is there someone who says no, that's absolutely ridiculous, let's call it from where you found it?
No, it generally comes down to the scientist who's doing the research. So I've named so far about, let me think, six new species. And one of them I actually named after my two colleagues who introduced me to paleontology and to ichthyosaurs. So these marine reptiles, they're not dinosaurs. They kind of looked a little bit like dolphins or sharks. And my two colleagues is Professor Judy Messere and another friend of mine, William Wall. So I named the ichthyosaur after them and called it Wallisaurus after Bill Wall, and it was called Wallisaurus Messere after the Professor Messere. And you generally can name it anything. So although one thing I should say, you can't name it after yourself. That is pretty frowned upon. Not that I would do that.
Frowned upon, come on. Amazing. Well, seriously, I've never asked these questions of a paleontologist before. And just finally, before you go, it's National Dinosaur Day this week. We've dedicated our whole show to it today, and there's a new TV show on Tiny Pop that you can tell us about.
It is, yeah. So it just so happens that on National Dinosaur Day, June the 1st, which actually sounds a little bit like something I've made up, an exciting new show lands on Tiny Pop called Gigantosaurus. A show all about 4 little dinosaurs who go on many exciting adventures. It airs weekdays at 7:30am and 4pm and weekends at 1:30pm. I will certainly be tuning in, and you can catch it on Freeview 207, UView 207, Sky 617, Version 737 and FreeSat 605.
Amazing, a dinosaur's dream, I reckon. It's Gigantosaurus on Tiny Pop. And Dr. Dean Lomax, thank you so much for joining us on the show. It's time for this week's Dangerous Dan, where we're going back in time 45 million years ago to have a look at a brand new creature that we've only just found. Now, there's a lot in this, all right, to get your head around, so do listen up, listen carefully. You know anchovies? Anchovies, which are small fish, very salty things that sometimes people put in salads or on pizzas. Yeah, I don't know why they did that either. It's kind of like pineapple. It just doesn't make sense. Anyway, scientists have discovered a species of fish that roamed the seas 45 million years ago, which they think is related to the anchovy, the fish you put on your pizza. But this one isn't small and harmless like the anchovy. It's huge and it was brutal. They had razor-sharp fangs lining their jaws at the bottom. They had one massive saber tooth at the top, meaning they were pretty formidable to everyone around them. They think that they were around 1.5 meters long. They were thick, they were powerful. Now the real question here is, how were they related to the simple anchovy that we still have today? These things went extinct millions of years ago. Because the anchovies are tiny things that slide around the bottom of the sea, but this was an ancient, extinct fish. It was a big, brutal hunter. Now, scientists don't know much more about it right now, but they think that there might be another link in the chain between the fish that explains how it got there. But listen to this. It was called, they're calling it Monosmilus chirolodes, which takes its name from a shape-shifting vampire demon from South Asian stories near where the fossil was found. So this creature, this massive fish with razor-sharp fangs, one huge saber tooth, has got a devastating name, perfectly fitting for a proper dangerous creature. We are travelling back in time once again on our dinosaur special of the Fun Kids Science Weekly and grabbing another Age of the Dinosaurs.
Age of the Dinosaur with Dinosaur Action Magazine, the #1 mag for dino fans.
Imagine going back in time, not 100 years or 1,000 years, but millions of years. To the Age of the Dinosaur. Welcome to the Jurassic Period, which was between 145 and 200 million years ago. It was a time when plant life began to flourish once again, as newly formed oceans brought rain to many parts of the world that had previously been nothing more than dry deserts.
Phew, it's really hot here.
Vast, humid forests covered much of the land, but unlike the forests you see today, the Jurassic forests were full of giant ferns and tall leafy green conifers, similar to monkey puzzle trees and giant redwoods. Under this towering canopy were smaller leafy plants similar to the ferns and horsetails that we see today. Plants weren't yet producing colourful flowers to attract insects. Instead, many produced cones full of seeds and pollen, or tiny capsules containing spores. It therefore wasn't a time to stop and pick a bunch of blooms. Not that you'd want to, with some of the animals around.
Uh-oh, something's coming.
With trees taller than houses, dinosaurs were built to match. Huge sauropods, some reaching more than 12 metres high, and others over 30 metres in length, roam the forests, reaching up high with their long necks to eat the rough leaves at the top of the tallest branches. Many lived and travelled in large herds, which helped ward off predators.
Whoa, look at that one, it's huge.
Ah yes, that's a Camarasaurus. Brachiosaurus and Camarasaurus were two sauropods you'd find in a Jurassic forest. Both were huge quadrupeds, meaning four-legged animals, with small heads but long necks and large bodies. The Camarasaurus had enormous chisel-shaped teeth that could be nearly 15 centimetres long, and they helped him to chew his food, something not all sauropods could do. Don't worry, they wouldn't be interested in chewing you and me. As vegetarians, they'd rather have some tasty leaves.
Quick, he's looking for more leaves. Duck!
Paleontology, pick.
Fossils help us understand what dinosaurs were like, but scientists didn't really start to examine fossils until only 200 years ago.
Do you know how a fossil is made? After the soft parts of an animal have been eaten or rotted away, the hard parts like the skeleton became covered in silt, sand or earth. Over time, these layers became deeper, and water flowing slowly through the rock brought minerals that started to replace the bone bit by bit. Eventually, these minerals totally replaced the original bony skeleton with an exact replica in rock, and therefore preserved for fossil explorers to discover millions of years later. Prehistoric animals and plant life can also be found in amber, which is formed when a sticky resin from trees sets hard. Scientists have found insects trapped inside amber, perfectly preserved for us to see today.
Age of the Dinosaur with Dinosaur Action Magazine, the #1 mag for dino fans.
Right, it's time for this week's Science in the News. The European Space Agency, ESA, has asked the company Airbus to make another part of the Americans' Orion Crew capsule. It will be the back end, and it's part of the mission that sends astronauts to the moon for the first time in 52 years. It will be the part of the capsule that pushes it through space. It's responsible for the power supply and for temperature control as well. Also, a clearer picture is emerging of why the asteroid that killed off the dinosaurs 66 million years ago was so bad. It wiped out 75% of all species, it hit the worst possible place on the planet, and new research also suggests it was at the most lethal angle. The angle that it hit the Earth at threw up rocks which covered the sky in sulfur. It started a long global winter, and at a different angle, in a different place, scientists think it may not have been so bad. And finally, scientists from the UK have created the first maps of microscopic algae which is growing on Antarctica. This is a little bit of a strange mystery. They've counted nearly 1,700 patches where this algae is turning the snow green. Turns out it's really important as well. They say they're pulling carbon dioxide out of the atmosphere, trying to clean the air, and they're also key to making nutrients in one of the most remote regions on Earth. And that is it for this week's Fun Kids Science Weekly. Thank you so much for listening to our dinosaur special. If you've got any questions, sciencey, that you want answered on the show, dinosaur or otherwise, you need to leave it for me as a review. Find the Fun Kids Science Weekly over on Apple Podcasts. There's a comment box at the bottom, write it there, give us 5 stars so I can see it, leave your name as well so I know who to say hello to. While you're on Apple Podcasts, it's one of the places that you can hear all of our brilliant science series. You've heard a few today. We've got loads more on there. You can also get them wherever you get your shows from. If it's not Apple, we'll be there. You can find us on the free Fun Kids app and at funkidslive.com. And Fun Kids, or a children's radio station from the UK, you can hear us all around the country on that DAB digital radio, on your free Fun Kids app, and as always at funkidslive.com.